Chapter 13 is going to talk about sustaining aquatic biodiversity. So really about our oceans, some of our freshwater systems, how they're being affected with things like overfishing and habitat destruction. So a little case study to start out. Lake Victoria, which is in East Africa, has seen its ups and downs. You can see the picture on the bottom of where it's located, kind of by Kenya, Uganda, and Tanzania, Rwanda, all surround it. So obviously they all draw from it. What's happened over the years is it's really lost its diversity. They were known to have a huge population of these teeny or small fish called cichlids. And what happened was they introduced the Nile perch. You can see the picture in the middle. The guy is holding it up. Obviously, that's a very big fish, and the reason they introduced it in the first place was because it's a lot of meat, and the people could thrive a little bit better off with it. Problem is, what happened is then the cichlid population went down because they ate all of them. And what happened as a result, those cichlids ate algae. We got huge algae blooms, not only from the cichlids not eating it, but more so from the nutrient input around it because of things like phosphates and nitrates running off of it and raw sewage and so on. So what happened is the cichlid population went down, the Nile perch population suffered afterwards, and what is happening now is the Nile perch population is going down, so the cichlid population is starting to go back up. So kind of a failed experiment with the whole idea, although not a bad idea in the first place to feed people, but it failed. So of course aquatic species are threatened by habitat loss, invasive species, pollution, climate change, overexploitation, and of course human population is really driving a lot of this, aka the HIPCO that we've talked about already. What the Pew Ocean Commission recommends is, of course, we pass a National Ocean Policy Act to protect our oceans, double the federal budget that we currently have to protect our oceans, have a fishery management based on preserving habitat, and set up a network of marine reserves. I'll talk about soon. Keep in mind our greatest biodiversity in our oceans is, in order, coral reefs, then estuaries, and then the deep ocean floor. A lot of people don't think we have great biodiversity in our deep ocean floor, but we do, because there's habitat and because there's the marine snow that comes down, all the dead and decaying matter that's above floats down to the bottom and is eaten. Biodiversity is much higher near the coast than in the open sea. As a matter of fact, the open to mid-sea really has the lowest biodiversity, again, because there's no habitat and not a lot of food supply there. There are photosynthesizers, but they can only support so much. In the bottom region of the ocean, much more than the surface region. As a matter of fact, the lowest marine biodiversity is in the middle depths of the open ocean. In the last 100 years, a couple things we've done. We've lost half of our world's coastal wetlands. We're filling them in, we're building on them, we're using them for aquaculture. 20% of our world's coral reefs have been destroyed. Sea levels have risen between 10 and 25 centimeters. We've destroyed more than a third of the world's mangrove swamps for fishing lanes and also for aquaculture. Bottom of the oceans have been destroyed by dredging operations in order to get big ships into regions, and also that trawling fishing has hammered it. Seaweed, of course, we need the ocean. We get things like seaweed for cosmetics, for pharmaceuticals. We get antibiotics, anti-cancer chemicals, possibly from the oceans too. So we really need this and be a little bit more sustainable. Ocean layers, and I don't believe this is really covered in the book, but you should know this. The top layer, which tends to be the sunlit layer, is the epipelagic. Pelagic means open water. That goes down roughly 600 feet, depending on the region and the cleanliness. The mesopelagic, meso being middle, about 600 to 3,200 feet down. And that's where we get things like bioluminescent creatures. Those are little protists that tend to light up. Very cool. Bathypelagic is anywhere from 3,200 to about 13,000 feet down. Abyss, or abyssopelagic, 13,000 to 19,000 feet down. So that we're talking 2-3 miles down to about 4 miles down. And the hadopelagic is below roughly 20,000 feet down, so incredibly deep. Keep in mind the deepest part of the ocean is off of Japan. So what are we doing? About 3/4 of commercially fished species are overfished. The idea of a McDonald's fish fillet, they may have to switch to something else eventually, because that fish is caught, I believe, off the coast of Madagascar, a very specific fish, which is a bottom dweller, which is very nasty. But we're eating so many of those fish fillets, it might be gone eventually too. Marine and freshwater fish have been threatened with extinction by human activities, of course, more than any other groups of species. A very important word is something called commercial extinction. Commercial extinction is when it's not worth the money to go after fishing, because it takes more money to go after fish than it is that money that you get out of the fish. The collapse of the cod fishery is kind of related to this. Cod is a very popular fish. Of course, fish fries in Wisconsin on Fridays are generally cod, and that's starting to collapse. What's happening is we're catching all the big fish, and those big fish are going away, so we have to fish what's called down the food chain. So we're now catching smaller fish because those big fish are gone or going to be gone very soon. And of course, we waste the catch. Invasive species are also hitting aquatic biodiversity. The picture on the right is purple loosestrife. We have that around this region. What it does is it chokes out our ponds and streams. Invasive species are a huge threat. They push out native species. They generally outcompete them. They disrupt and degrade whole ecosystems. A couple examples is the water hyacinth in the Lake Victoria. That's when the algal blooms are occurring. That's exactly what it is, that plant. And then what happens is it grows so prevalently that the light doesn't reach further down. Asian swamp eel, waterways of South Florida is taking over. Purple loosestrife, of course, it's indigenous to Europe. That was actually brought over because it's a real pretty plant, but it's actually being taking over. I know in Wisconsin the DNR is using a weevil species, a little beetle, that actually will eat these things, so they're raising a biological control method. Little focus group here in Wisconsin near Madison. We have a lake called Lake Wingra. It's incredibly eutrophied because of all the farms around it, and it contains a lot of invasive species like purple loosestrife and the common carp. So what's happening is a professor over there is actually trying to remove the carp from an area of the lake. They're trying to, of course, one of the laws that's prevented people, residential people, is we can't put phosphorus on our lawns anymore. So that should help, but the farmers still are wreaking havoc on that too. So you can see the picture on the top right is an incredibly eutrophied lake system, and eventually that's going to really populations, and really nobody wants to live there. A couple of international agreements. Keep on the idea that international agreements are great, but they're not always followed through. There's the United Nations Law of the Sea. Every country has sovereignty rights over 12 feet offshore, so that basically nobody else can fish within 12 miles of your coastline, and you actually have something called exclusive economic, or EEZ, 200 miles off the coast, which is pretty much the same thing, where you pretty much have the rights and other nations shouldn't come into your zone. The problem is, of course, hard to maintain, hard to know if other people are in there, plus there's so many countries that are close together. Integrated coast management is the idea. It's a community-based idea to use coast more sustainably. So it's clubs like the Sierra Club coming together and trying to prevent pollutants from going in to the water, to prevent other contaminants, to prevent habitat destruction and the like, ideally zone and protect the portions of the zone. The World Conservation Union, known as the IUCN, has established marine protected areas that you cannot harvest or protect or disrupt. They're called MPAs, or marine protected areas, which are really nice. The problem is they're only 0.01% of the world's coast. Australia is really good at this. This is the idea that you don't touch it. It just, you leave it as pristine. You can't fish it. You can't add pollutants to it. You can't destroy habitat, anything like that. The United States is way behind on the 8 ball on this one. We don't have a lot of marine protected species, or areas rather. We have some off the coast of Florida, but not much at all. Studies do show that fish populations grow fast when not pressured. So let's just let nature do as nature, and we'll be good. Population growth and pollution obviously can affect aquatic diversity. We talked about this already too. Nitrates and phosphates lead to eutrophication. You can see the picture at the right. Eutrophication is going to grow a lot of plants, and those plants are going to die, and then eventually what happens is that sediment fills in the lake, and then we get toxic pollutants and everything, and then that fills in there, and of course we can actually systems. That's a big concern with Lake Wingra over in Madison. Climate change, we know, is a growing threat too. Global warming, we know sea levels are going to rise. You can see the picture on the right. If sea level rises up as predicted, areas like New York, Philadelphia, D.C., Richmond, Savannah, Miami, New Orleans, Memphis, Houston, they're going to be gone. What happens is coral reefs are threatened because the polyps inside die, the algae die, and they get what's called coral bleaching. Swamp and some low-lying areas are going to be affected. The drowned out many coastal productive areas, as I mentioned, so threat. Something we'll hit down the road a little bit more. Protecting mangrove swamps, we need to do this. They're excellent habitat. They reduce the effects of sea rise. They reduce the effects of tropical storms like hurricanes and tsunamis. Much cheaper than building concrete walls out there, and they're much more natural. The mangrove swamps in Indonesia are really being dominated and taken over, especially for like their fishing. I may have talked about this before, but really bad for, obviously we eat fish. It's a big part of our diet in many nations, not necessarily the United States, but like in Southeast Asia. Bad methods of fishing are things like trawler fishing, where they have very heavy weighted nets and they just drag the bottom of the ocean. Purse seine fishing is in the right. They find a school of fish, such as tuna or cod, and scoop them up. Long lining, that's when banned in the United States. That's when we put about up to 80 miles worth of hooks out, and they have a lot of bycatch. Things like sharks get tangled in them, sea turtles, and the like. And of course, drift net fishing is the one on the right, and that is the idea that fish just swim into that and then they pull it out. Again, all of these devastating on our ecosystems, particularly with bycatch. That's it for part one.